Hello, mathematicians. Today we're going to be learning how to solve equations with variables on both sides. So here I have the problem 7x plus 3 is equal to 2x plus 13. And first things first, when we're keeping our equation balanced, it is similar to using a balance or a seesaw. So here you see a model of a balance with algebra tiles on it. And here we see a model with a seesaw with algebra tiles on top. And so this just emphasizes that whatever we do on one side of the equation, we have to do on the other side of the equation to ensure both sides of the equation are equal. So that basically means if I were to remove 1x on this side, I would have to remove 1x on the other side to keep this balanced, because if we don't, it will tilt over. So we know that the expression 7x plus 3 is equal to the expression 2x plus 13. So because they're both equivalent, we have to keep them balanced. So just as we said, if I take 1x out here, to keep it balanced, I have to take 1x out on the right side. And then I could take another x out on the left side and remove another x on the right side. So basically what I did is I took away 2x from each side to keep it balanced. And now I can't take another x away from the left side because I only have x's on the left side and I no longer have any x's on the right side. But on both sides I have 1's. So I could take this one out, and then I have to do the same thing on the right side. And then I take another one out, and then I have to do the same thing on the right side. And then I take another one, and then I have to do the same thing on the right side. So we're left with 1, 2, 3, 4, 5. 5x is equal to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10. So we know that 5x is equal to 10. And so with that being said, we know that for each one of these x's, so if I took this out, for each one of these x's, I have to have an equal amount of 1's. So if I spread them out, so we know that 5x is equal to 10 because that's what we ended up with on both sides. But every x is equal to 2 because we could split up the ones evenly amongst the x's. So 1x is equal to 2. So x is equal to 2 in this case. So now let's say we just have the equation without a model. We could solve it as we normally would. Our goal would be to isolate the x. So I'm actually going to show you two methods that we could use for this. So we have 7x plus 3 is equal to 2x plus 13. And what makes this difficult to solve is the fact that we have x's on both sides of the equation and we have constants on both sides of the equations. So what we can do is we could rearrange this so that we have all of our variables on one side and all of our constants on the other side. So for this first method, I'm going to show you guys how to get all our variables on the left side and all our constants on the right side. So if I don't want any variables on my right side, I'm going to take away this 2x, and that cancels it out. But whatever I do on the right side, I have to then do on this left side. I'm going to subtract 2x, and now 7x minus 2x is 5x, which is what we ended up with before, plus 3 is equal to 13. So now I have 5x plus 3 is equal to 13. I want to get all my constants on the right side. So in order to get rid of this plus 3, I'm going to use the inverse operation and subtract by 3 on both sides. And now I'm left with 5x is equal to 13 minus 3 is 10, and that's what we had before. So now that I have all my variables on the left side and all my constants on the right side, I could absolutely solve this easily. And I could have done so in this step before as well. But I just wanted to show you guys how we're just rearranging it to make it easier to solve and isolate x. So now that I have 5x is equal to 10, 5 times x is equal to 10, so we're going to divide both sides by 5. And so 5 divided by 5, it cancels out. So x is equal to 10 divided by 5, which is 2. And now the other method I'm going to show you is instead of moving all our variables to the right side, we're going to move our variables to the left side and our constants to the left side. So variables to the right side, constants to the left side. So if I subtract 7x here, I have to do so on the other side. And 7x minus 7x cancels out. On the left side, I'm just left with 3 is equal to 2 minus 7. So keep in mind our signs are not the same. So since the signs are different, I'm going to subtract and keep the sign of the number with the greater absolute value. So if I subtract, I get 5x. And then the sign of the number with the greatest absolute value is 7. So negative 5x. And I'm going to bring down my positive 13. And now because I rearranged it so that my variables are on the right side, I'm going to take my constant and move it to the left side. So in order to get rid of that plus 13, I have to subtract by 13 on both sides. And 3 minus 13, the signs are different, so I'm going to subtract. I end up with 10. And I'm going to keep the number with the sign of the number with the greatest absolute value, which in this case is negative 13. So negative 10 is equal to negative 5x. And now I have negative 10 is equal to negative 5x, which means that negative 5 times a number will give us negative 10. So to isolate our x, I'm going to divide both sides by negative 5. That cancels out. Negative 10 divided by negative 5 is positive 2. And negative 5 divided by negative 5 is just 1. I don't need to write the 1. I could simply write x. So doesn't really matter if you get your variables on the left side or on the right side. We still get the same answer. So in this first example, we moved our variables to the left side of the equation and our constants to the right side of the equation. In this second method, we moved our variables to the right side of the equation and our constants to the left side of the equation, but we still ended up with the same answer because in both cases we made sure that our equation was still balanced by doing the same thing on both sides. In this example, we have negative 2 minus 5x is equal to 3 minus 6x. So if you notice, here I have negative 2, but here I have positive 3. So I'm not going to start off with that because we have negative x's in common on both sides. So I'm going to do that first. So if I take one negative x, I have to do the same thing on the right side. And I'm going to keep doing that until I can't anymore. Alright, so that's it. So now I have negative 2 is equal to 3 minus x. So even though I can't get rid of these, even though I can't get rid of 3 on both sides or positive 1, another thing I could do to cancel this out is a positive and a negative cancel out. So if I add 3 negatives on this side, it'll cancel these out. But then I also have to add 3 negative 1s on this side. Okay, so here they don't cancel out, but here they do. So I'm just going to get rid of these completely. And now I have -5 is equal to negative x. And now we know that this negative in front of x is the same thing as -1. So in order to get rid of it, I would have to divide everything by -1. So -5 divided by -1 is 5, which is equal to x. So if we want x by itself, we do have to divide by that -1, and this becomes positive. So if we multiplied these two by -1, this would be 5 1s. And instead of having this negative x, we would have positive x. So this would be positive, and we would get rid of that. Okay, so because we multiplied both sides by -1, we would end up with 5 is equal to x. So now if we weren't modeling it, and if we just took this equation to solve it, again, there's 2 methods that we could go about solving it. So the first one is to get all the variables on the left side and all the constants on the right side and then solve, or vice versa. So I'm going to show you guys both ways. Alright, so here, if I want to get all the variables on the left side, I would have to first get rid of this one here. So 3 minus 6x, I would have to add 6x on both sides to cancel that out. Sorry. So this cancels out, and now I'm left with -2, -5 plus 6, so the signs are different, so we subtract, so that's 1x, and then we keep the sign of the number with the greatest absolute value, which in this case is 6, so that's -2 plus 1x is equal to 3. And now that we have all our variables on the left side, we have to get all our constants on the right side. So in order to get rid of this -2, I'm going to have to add 2 on both sides. This cancels out, so I'm left with 1x, or just x, is equal to 5. And since x is already by itself, I could just leave that alone. So x is equal to 5. That is the same thing we got before. And now the second method would be to get all our variables on the right side and all our constants on the left side. So if I want to get my variables on the right side, I have to add 5x on both sides. That cancels out. So now on the left side, I'm left with -2 is equal to 3. And then -6 and +5, since the signs are different, I'm going to subtract. I get 1x. And now I take the sign of the number with the greatest absolute value, which is 6. And because 6 is negative, this is -1x. So now I have to get all my constants on the left side. And in order to do so, since this is a positive 3, I have to subtract by 3 on both sides. I end up with negative 2 and negative 3. Since the signs are the same, I add 5, and then I keep the negative sign. So negative 5 is equal to negative 1x. And now, since I want to isolate x and get it by itself, I do have to divide both sides by negative 1 so that the x is by itself. Negative 5 divided by negative 1 is positive 5, which is equal to x. So in both cases, we do get the same answer. So in the first example, we moved our variables to the left side of the equation and our constants to the right side of the equation. And in the second example, we moved our variables to the right side of the equation and our constants to the left side of the equation. And we ended up with the same answer because no matter what we did, we made sure to keep our equation balanced. All right, so here I have another example. I have 2x plus 3 is equal to negative x plus 4x. So in this case, if we look closely at the right side of the equation, you'll notice that both of these have variables. So I have 2x, which has a variable, plus 3, which is a constant, and then on the right side, I have no constants, I just have variables. So here I have negative x plus 4x, and negative x and a positive x cancel each other out. So these cancel each other out, so I could get rid of them completely. And so because I had negative x plus 4x, that simplifies to 3x. So now I have 2x plus 3 is equal to 3x. And so we're going to do the same thing we did before to get our equation balanced. So since there's no 1's on both sides, I'm going to just take away 1x here, and then take away 1x on the right side, and then 1x on the left side, and 1x on the right side. And now, this one was pretty simple because now I'm left with 3 is equal to x. Okay, and that's it. So if we didn't have our model, we would write out 2x plus 3 is equal to negative x plus 4x. The first thing we would do is, if we did have variables or constants that were on the same side, we could simply combine them. So we could easily combine this so that it reads 2x plus 3 is equal to 3x. And now if we're going to do, so we're going to do it both ways. So I'm still going to take my variables and move them to the left side for our first example, and then I'll do the opposite in our second example. So by doing so, I would subtract 3x on both sides. So positive 2x and negative 3x, the signs are different, so I subtract. I end up with 1x, so I don't have to put the 1 in front of it. And because the number with the greatest absolute value is negative, I do make that negative. So negative x plus 3 is equal to 0 because those cancel out. And now I'm going to move my constant to the right side of the equation. So since it's plus 3, I'm going to subtract by 3 on both sides. And I end up with negative x is equal to negative 3. And in order to get the x by itself, I'm going to divide both sides by negative 1. So negative 1 divided by negative 1 is just 1, so x is equal to 3. And so we're going to solve this again. And this time we're going to move all our variables to the right side. So first things first, we simplify, so same thing. So we simplify by combining our like terms. And the only reason we're able to simplify is that the variables are both on the same side, so it's okay. And now, same thing, I'm going to get my variables on the right side. Going to subtract by 2x, subtract by 2x. This cancels out. I'm left with 3 is equal to 3 minus 2x is 1x, so 3 is simply equal to x. So in both cases, we got the same answer. In the first example, we first combined like terms, and then we moved our variables to the left side of the equation and our constants to the right side of the equation. And in the second example, we also combined like terms first, and then we moved our variables to the right side of the equation and then our constants to the left side of the equation. And we ended up with the same answer because no matter the case, we made sure that our equations stayed balanced. All right, so here's our final example. And in this problem, we have 4 minus 3x minus 2x is equal to 2 minus 4x. So same thing. If we look at the left side of this equation, you'll see that we have like terms here. So we have negative 3x and negative 2x. And if we combine them together, we have negative 5x. So this simplifies to 4 minus 5x, negative 5x, is equal to 2 minus 4x. And so we're going to do the same thing as we've done before. So in this case, I have positive ones on both sides. So if I take one on the left side, I have to do the same thing on the right side. And then if I take another on the left side, I have to do the same thing on the right side. If I take out a negative x on the left side, I have to do it here too, and I'm going to keep doing that. Okay, and so now, if I do want to get rid of this negative x here, if I add a positive x, those cancel out, but I'm going to have to add a positive x to the opposite side. So these cancel out, and now I'm left with 2 on the left side, so 2 is equal to x. So x is equal to 2. Okay, and now we're going to solve it using our two methods. So first things first, we're going to combine like terms on the left side. So we're going to get all of our variables on the right side. So I have to add 4x on both sides. Negative 5x and positive 4x, the signs are not the same, so I'm going to subtract, and that gives us 1x. And since the number with the greatest absolute value is negative, it's actually minus 1x, or just minus x, is equal to 2. And now I have to get my constants on the right side. So in order to get rid of that positive 4, I'm going to subtract 4 on both sides. That cancels out. So I'm left with negative x, or negative 1x, is equal to 2 minus 4. Since the signs are not the same, I'm going to subtract. And when I subtract, I get 2. And then the number with the greatest absolute value is 4, so I keep the negative sign. And now finally, if I want to get x by itself, I have to divide both sides by negative 1. So x is equal to 2. So we're going to do the same thing, but this time we're going to move our variables to the right side and our constants to the left side. So first things first, combine our like terms that are here both on the left side. So 4 minus 5x is equal to 2 minus 4x. And if we want to get our variables on the left side, I'm going to have to get rid of this negative 5x. And in order to do so, I have to use its inverse operation, which is plus 5x, and add 5x here on this side. So this cancels out. On the left side, I'm now left with 4 is equal to 2. And then I have negative 4 and positive 5. Since the signs are different, I subtract. So I get 1 when I subtract, so 1x or just x. And since the number with the greatest absolute value is positive, this is plus x. So now I have 4 equals 2 plus x. And in order to get my constants now on the left side, I have to subtract by 2. 4 minus 2 is 2, is equal to x, and that's it. I'm done because there's no other coefficient in front of x other than 1. And so that's it. That's how we solve equations with variables on both sides.